Okay, for this question, two blocks X and Y at different temperatures are placed in thermal contact with each other until they reach thermal equilibrium. Block X and block Y are of the same material. The mass of block Y is half of block X. Change in temperature of block X has magnitude delta T, and the change in internal energy of block X has magnitude delta U. What is the change in magnitude of temperature of block Y and the change of magnitude in internal energy of block Y? And then these are our choices over here. We need to verify Y. The answer is indeed letter D. Okay. Well, first things first, notice that in the question, it tells us that the materials are the same. Okay, it says it right here. Block X and block Y are of the same material. Now, the implication of that, because the materials are the same, that means that you have the same specific heat capacity. All right, so I'll note that up here. So same material implies you will have the same specific heat capacity or value for C. Okay, recall the formula that we are using for this unit for specific heat capacity will be Q is equal to MC, change in temperature. Okay, so another implication of this is that if you have the same specific heat capacity, we also take into account that we have thermal equilibrium. Okay, it tells us here that they become in contact with each other, eventually reaching thermal equilibrium. What does that mean? That means that your change in U, which refers to the change in internal energy, must be the same. Okay, so again, the reason why delta U will be the same for both blocks X and Y is because they are in thermal equilibrium. Okay, so that means our only options are either letter C or D. So the problem is how can we express the magnitude of change in temperature of Y? Okay, well, because again we are referring to this formula over here, Q equals mCT, I could kind of, before doing anything else, illustrate that I have two blocks, X and Y, Y being half the mass of X. So I have something that looks like this roughly. Okay, we are also told in the problem that the mass of block Y is half that of block X. Okay, so this illustration here, and then this is the mathematical expression to show that. All right, we know that this block also has a specific temperature. All right, so this block Y has a certain temperature initially. This block X has its own temperature. Okay, so what can I do? Well, I can basically express or use this equation here for both blocks X and Y, set them equal to each other. All right, and then I will be able to solve one temperature in terms of the other. So how will that look like? I will have, starting with block X, so the mass of block X multiplied by its specific heat capacity, multiplied by the change in temperature for block X, equals to the mass of block Y. But instead of putting mass for block Y, I will write it in terms of X. So that's just going to be the mass of X over 2, multiplied by the specific heat capacity times the particular temperature for block Y. Okay, because the specific heat capacities are the same, I can easily cancel my C's. All right, I'll move my 2 to the other side. So this is just algebraic manipulation at this point. I will have the following. Okay, now at this point my masses will once again cancel, and if I get Ty by itself, it's really going to look like this. Okay, in other words, Ty is equal to 2 times T of X, and okay, just omit the X and the Y's. That really corresponds to this over here. Okay, so 2 times the temperature of X, we assume that this is in terms of X. Okay, and hence our answer must be letter D.